Okay. Can you see the screen? Okay, fine. So today, inshallah, we are going to discuss our last topic, that is threads. Threads in Java. Okay. Threads are basically parts of the program where in which the whole program is divided into pieces for execution. This is using basically we keep it for making the execution of the program faster by dividing the program into pieces or parts, so that each part will execute simultaneously if it is in multiprocessor, or sequentially if it is in a single processor machine. Let me just put this in recording. M257. Java threads. Okay, fine. So today, inshallah, we're going to talk about threads. Just 1 minute, sorry. So threads are the Java programs in which the whole program is divided into small pieces. So we'll see today, inshallah, introduction to thread and how to create threads in Java. What are the different states of a thread? When the thread is generated, it goes through a number of states. Fine. So we'll see what are the different states, or you can say a life cycle of a thread. So how the thread will be generated after the generation of the thread. What are the different stages it goes on till it completes its task. So every thread you can consider as a task from the program. Basically, the whole program is divided into threads, and every thread is a task or it's a job, okay, in the processor. So processor will take that thread, process it, fine, in the way of running the program. So all the threads will be executed to complete the program. Fine. There is no thread left behind, and the program is completed. Every thread of the program will be executed completely, but in a different fashion. So if we have a multiprocessor machine, every processor will take a thread and process it parallelly. Fine, in parallel. If it is a single processor, then there is some priority for the thread, sequential execution, time allotment, fine, for every thread for execution time, priority and all comes in. So in Java, we have classes, because we all know that Java is all about classes and objects. So definitely we all have the classes in Java that supports these thread operations, and that allows us to make the threads in our programs. So we'll see inshallah how we create the threads in Java, different states of a thread. So we'll start with the introduction to threads. Java is a threaded language which allows programs to do several things at once. So thread, because by creating the threads, many threads are executed, that is allowing several threads, okay, at one time. Now every thread is a separate activity within a program. Every thread, or you can say threads, are separate activities within a program, each of which has a beginning and end. That means every thread has a start and an end. That is, once the thread is generated, then thread do its execution. It goes to number of states until it finishes its job. For example, you might want to monitor the keyboard for a key being pressed. At the same time, you want to track the mouse movement using by the user and repaint the skin. So each of these tasks can be thought as a single thread. In a single program that you are pressing the same key, at the same time you are moving the mouse, and you want to keep track of both. Fine. So every task here, like pressing the key in a keyboard and moving the mouse pointer, fine, can be tracked as what? A thread. So two threads, we can say. Java system has a component called scheduler that makes the decision about which thread to run next. So the schedule will be made for the threads which makes the decision about which thread will be executed next. Because a program may have many threads, 10, 20, hundreds. So there will be scheduler that makes the decision about which thread to execute next. Threads are not actual static codes itself, but rather they are dynamic process of executing the code. They are not a static code, but they are dynamic codes. That is because sometimes the threads are generated at the time of execution. Fine. So threads are generated at the time of execution, so they are dynamic. So far, all programs that you have written had only one thread, and this has been the main method, because we write every program and execution is through the main method. So the main method is only one thread. So till now what we did, all programming has only one thread. Now let's look into the concurrent system, because threads, a program may have many threads, and these threads can be executed in different machines. If the machine or a computer, machine means here computer, if the computer has multiprocessor, so all the threads or the number of processors that is in that system will take that number of threads and execute in parallel. Okay, and if not, it is a multiprocessor and it has only one process, like our PC. This is my PC machine or my laptop. Similarly, your computer, it may have only one processor, and once one processor, it means it can execute one thread at one time. Fine. So we need to understand the concurrent system here to see how the processing is done in the concurrent system. Now, concurrent system, it is an area of computer science that represent concept surrounding the use of thread. A concurrent system consists of a collection of separate activities or tasks or jobs, you can say, that are simultaneously at some stage between their starting and finishing point. So that are executed simultaneously, fine, at some stage between their start point and the finish point. In such systems, each task is made as a thread. Every job or an activity, or you can say task, is made into a thread. If it is a multiprocessor computer, in a multiprocessor computer, each thread can truly run at the same time. So that means simultaneously it can run as all other threads. It depends on the number of processors available. If there are 3 processors available, 3 threads will execute simultaneously. If there are 10 processors available, 10 threads will execute simultaneously. So of course it depends on the number of processors. On a single computer, like our PC, the CPU can carry out one set of instructions at a time. So in this situation, the threads will share the CPU and the operating system will allocate a small block of time for each thread. So let's say, for example, 2 nanoseconds, 3 nanoseconds, or 10 nanoseconds. So the CPU will allocate, the operating system will allocate a time to use the CPU, wherein which you have a single processor, like our machine we have. And if it is a multiprocessor, like servers and all, there, of course, the execution will be simultaneous. It depends on number of processors it has, and that number of threads can be executed at one time. So that's about the concurrent system, how in a system the threads can be executed. So in which we see 2 cases. One is with a single processor, the other is with a multiprocessor. Now a thread is treated as an object in Java. Coming to Java as a thread, creating the threads in Java, or how the threads are dealt in Java. Basically, a thread is treated as an object in Java. Thread class is found in java.lang library. So you don't need to import anything here because lang library is by default available in every program. Right? So if in a program, the library is available by default, so no need to import anything here. Okay. So thread class has a number of methods for creating the thread, destroying the thread, and modifying the threads. There are 2 ways that you can create the threads in Java, or you can say threads classes can be defined in 2 ways in Java. The first method to create a thread or to define a thread in Java is by inheriting from the thread class. That means that you need to extend the thread class. You need to extend the thread class. This method is used if you wish to inherit from only one class, that is the thread class, because we all know that multiple inheritance is not possible in Java except the interfaces. So thread is a class. So if your class is not inheriting from any other class, then you can use this inheriting a thread class to create the threads in your program. So that's number 1. Number 2 is by using interface. Here comes when if you want to inherit from any other class and at the same time you want to create the threads or you want to implement the threads, then you can implement this runnable interface. Implement the runnable interface. defining the thread by means of implementing the renable interface is used when you want to inherit from other classes except this thread class. So two ways, one is by inheriting from the thread class, the other is by implementing the renable interface. So we'll see like how the extension of the thread class, that is inheriting from the thread class, is done, and we'll see the output also here. Okay, the general approach here is that define a class that extends the thread class and override the run method. Run method, actually this is from the thread class. Override the run method and write some code in the run method. So in the run method, you should write the code that you wish to run when a particular thread is started. Then create an instance of the above class and start running the thread by calling the start method. So let's put this in NetBeans. So what we do here is that we'll write a class here, new Java class, call it as in where am I. Fine. Now this class will extend the thread class. Okay, extends thread. Fine. So after this, let me put this down. Now on this, let's put a variable int n and create an object of this. I mean constructor public where am I of int n is equal to, let me say n1 just to differentiate. Okay. Now we have to override the run method. Okay. So you can see that the run method is does not return anything. It's void. Okay, and does not take any argument. Fine. So you just write the void public void run, and you put here what is the code that you want to start when you want to create, when you create a thread. Okay. So let me put this as for int I is equal to 0, I less than n, I plus plus, and put a system dot out dot println and in thread number. N here will be the thread number. Okay, fine. Now this is my class in which I have implemented the thread, that is by extending the thread class, and I override this run method. Okay, to test it, we'll go to the main method. Let me put this in comments. Yeah, here is our main method. Yeah. In the main method, we will create an object of the class where am I. O1 is equal to new where am I of 1. So object 1 is okay, or you can say thread 1, then where am I, object 2 or thread 2 is equal to new where am I of 2. Okay, then where am I object 3 is equal to new where am I of 3. So 3 objects are created. Now I will start the threads of these 3 objects, that is O1 dot start. Okay, then I will start for the second O2 dot start and O3 dot start. Fine. Now let me run this one and see how the threads are executed. Yeah. Now you see that thread 1 we passed only one value, so it executed only one time. Thread 2 we passed number 2 times, thread 2 will be executed. Thread 3 times will be executed. Now what is the thing is that first we start with the thread 1, that is start. But what you see, the first one executed is thread 2, right? Thread 2. Then thread 3 times. So first thread 2 is executed, finished its job. Thread 1 finished its job, then thread 3. So this is the schedule is given. The schedule is given from the system, from the CPU. Okay, sorry, from the operating system. Fine. So we'll see is a kind of different output. A kind of different output. Now, if you want to and get it more about it, let us run it and for 100 times instead of n times. If you run it for, let's say, 100 times, you will see that every time after few seconds, few nanoseconds, you can say, different thread will be executed. So we have 3 threads here basically. Fine. So I say that every thread will execute this loop 100 times. You see here now, thread 2 is 2, 1, 2, 1, 3, 1, 2, 2, 1, 3. So it starts from thread 1 only one time, then it gives a space for time for 3 times to print thread 3. Then it is giving time for thread 1, then it is giving thread 3, 1, 2, 3. Since it is a single processor, my machine or my laptop is a single processor. So now here you see that different threads are executed at different time because the time allotted for every thread is limited. Okay, is limited. So the scheduler will allocate the time, fine, for the threads, and for that period of time the thread will be executed. We'll get the CPU and will be executed. When the time finishes, it goes on wait and give the time for another thread, for the next thread. Fine. So you can try also at your in your laptops this program and just to test like how the threads are executed in your PC. Fine. This is the first approach, using the threads. The second approach is by implementing the runnable interface. Before we implement this runnable interface, I just want to ask, do you have any questions? Any questions? So it's a simple topic. I hope everything is clear to you all. Yeah. Now let's move to another method of creating the threads by implementing the runnable interface. This approach is used when you want to inherit from any other class and also want to use the runnable interface. So in this case, this approach can be used. This approach is of creating a thread by implementing the runnable interface. Here the thing is that when you implement the runnable interface, of course, you're going to override this run method, fine, and you need to create the threads here by using the thread class, as you see here. As you can see here, for every object, you need to create a thread of it. Fine, we create an object here, place 1. Now for that object, I need to create a thread. Okay, so here then I will call that thread to start. Okay, so one step is more here, is that after you create an object of that class where you are implementing the runnable interface, you need to create a thread for that object. So the steps are: first you define a class, implement the runnable interface, override the run method, then create an instance of the above class, then create a thread that runs the instance, then start the thread using the start method. Fine. So let us put this in NetBeans. Let me change this to implements runnable interface. Okay, and similarly override the run method. So override is done here. Okay, then after this, when it goes to this one, creating an object of this, so you can see the red line over here, that object will not have the start method. So what you have to do is that you need to create a thread here. Thread T1 is equal to new thread of object 1. So T1 is now the object, thread object, on which you can invoke the or by which you can call the start method. Okay, similarly I have to create for the create a thread for the second object. So I'll create thread T2 is equal to new thread of O2. Fine, and I'll start here from the object T2. And similarly for 3 also, we create thread T3 is equal to new thread of object 3. Okay, and I'll call this T3 dot start. So this way, what is that you can create the threads by using the implement, by using runnable interface. Okay, so this is basically possible when you want to inherit from other classes, and also at the same time when you want to implement from the when you want to create the threads. So you can see here, the first the thread 3 will take the time, and then thread 1 will take the time, then thread 2 here from here will take the time, and so you can see the thread 2 got mashallah long time of the CPU. Okay, then it comes from here thread 1. Okay, so in this way the thread will be created and executed. Fine. This is by using the runnable interface. Okay. Is it clear how to create the threads by using by these two approaches? Anyone has any question on these two approaches? Students online, do you have any questions on these two approaches? There is a question, where do you use the threads? We can use the threads in our programs, like wherever we want to divide our whole program into pieces, and the execution will be done simultaneously. Basically, it is good when we have multiprocessor systems, and in the big application programs where we can run two different things at the same time, or two different jobs at the same time. Threads can be used there. Fine. As you see that here we created three objects as three different threads. So three objects are executed simultaneously. If it is a multiprocessor system, so those three objects will work simultaneously. Okay. And if it is not a multiprocessor system, then it will go one by one. It will get some time. Thread 1 will get some time to execute. Then thread 2 will get some time. Then thread 3 will get some time, and so on. Clear? Okay. Now we'll see different states of a thread. When the thread are created, when threads are created, what are the different states it goes through? Okay. So we call that as in thread states. So we need to look at various states of the thread that can be in, and how the thread might move from one state to another state. So a thread is basically, it goes in through the 5 different states, and at a particular time it can be one of the 5 states. So it means that the threads will pass through 5 states or 5 stages, and at particular one time thread can be at one particular state at particular time. The 5 states of the threads is, first one, the initial state, which you can see here. Okay, when we create a new thread, the initial state is when we create a new thread. That is when we create a thread object. Fine. And before calling the start method. Before calling the start method. Number one. Then thread can be in runnable state. Runnable state, it means it is ready to run. It's not running, but ready to run. That is when you call the start. When you call the start. Fine. Then thread can be in running state, which means that the thread is executing and running in the CPU. Then thread can go into the block state. Fine. Block state, it means what? Is waiting for something. Either the thread has finished his time, the CPU time, or thread is waiting for something else, like input outputs, or waiting for some other job to done. Thread can be in finished state. It means that the thread has finished its job. Fine. Done. All the thread execution is done. Okay. Now let's go into one by one. The initial state. Movement of threads from one state to another state is gone by the number of methods from the thread class and the object class it has, and the operating system and other external factors. So the movement of thread from one state to another state is based on two things. One is how many number of methods from the thread class and in the object class it has, and the operating system and the other external factors like the CPU schedule and the operating system schedule and all. So note the following in the figure. First, a thread is put into the initial state by means of using the new operator. When you create a thread here, like say for example here, by using a new operator, now the thread is in initial state. After this, the threads are in initial states. That's what here it is. The start method moves the thread into the runnable state. It means that when you invoke this start method, which is this one, when you invoke this or when you call this start method, then the start method will be in what? The start method will be in, when you call this start method, the thread will be in runnable state. So that means that the thread moves to the runnable state, which is here. So this does not means the thread is running. It means the thread is ready to run. The thread is runnable state. It means what? It means the thread is ready to run, but it is not running. Okay. At certain times during the execution of the program that contains the thread, Java system will look at the runnable threads. What are the runnable threads or ready to run threads? Fine. And will select one to execute the thread. It can be more than one threads runnable in the runnable state. So the Java system will select one of them for execution. Okay. And move the thread from runnable state to the running state. So it comes here in the running state. Running state here, it means that the thread is running now. So how it will move? It will call the resume method. It will call the resume method. Okay. When a particular thread is chosen, it is run method is invoked and the thread can begin execute. It's now in the running state. It's run method. Run method where we see in the class run method. So object 1, for example, thread 1, its run method is executed. Fine. So it is in running state. So when running state finishes executing, it moves to the finish state. So that means that when the thread finished the execution, I mean everything is finished, all the execution of the thread is finished, the job is done, the thread job is done, then it will move directly to what? It will move directly to the finished state, which is here, end of run, that is end of run. Okay. Now, however, the thread may run out of its allotted CPU time. So let's say, for example, we have a thread 1, okay, which is executing. Now let's say if thread 1 has got 10 nanoseconds from the CPU for the execution, but thread 1 did not finish its job in 10 nanoseconds. Then what happens is that it will go back to the runnable state. So if it is time is out, so you can see the time out will take the state to the runnable state again, to the runnable state. Okay. Or it may invoke this yield method. Okay. So however the thread run its allotted CPU time, alternative it may invoke the yield method to give away to other threads of equal or higher priority. In both the scenarios will cause the thread will go back to the runnable state where it can at some point be chosen by the Java runtime system back to the running state. So two things that makes the thread from running state to the runnable state again is one is timeout, the allotted time is finished but the job is not done by the thread. that will directly go to the runnable state, or it can invoke, the other threads can invoke the yield method. What can be the other threads? The threads which has an equal or higher priority than the thread which is executing. Okay, so that it will take the time, it will take the CPU and put that current running thread into the runnable state. Okay, so you can say that two things that will make the thread from running state to the runnable state again is yield or timeout. Okay, once it is back in running state, it can carry out with execution by its run method at the point where it left off. From the runnable state, again it comes back to the running state. Okay, it can carry out, continue the work, not from the beginning, from where it has stopped. From where it has stopped. Fine. So this indicates by the resume method. Okay, resume the thread from where the thread has stopped. From where the thread has been stopped. Okay. Fine. Now from the running state, a thread may move to the blocked state. Blocked state because of the delay in the input output, or because of the sleep method, or wait method is invoked. Let's see what is input output first. Let's say that thread T1 is running and T1 needs some input. Enter the value, for example. So at this point of time, till you enter the value, till it gets the input, the time of the CPU will be given to another thread. And make the thread in the blocked state. So it means that the thread is blocked, waiting for the input or the output to be finished. And then once the input output is finished, it will go back again to the runnable state, waiting for resume call. So this is the one case that a running thread may go to the blocked state. Okay, and from the blocked state, once it finished the input output, then it will go to the runnable state, wait for the resume to get it again running. The other is sleep method. A sleep is a static method of the thread, so can be called in any program, even those that does not use the thread class. When invoked, it puts the thread into sleep for a specific number of milliseconds. Fine. For example, 1000 milliseconds. If you want to keep the thread blocked, or you want to put the thread in sleep, fine, after some point. So the thread will go into sleep for 100 milliseconds. That will be in the block. Fine. Once the time finish, 100 millisecond finish, once the sleep ended, it will again go back to the runnable state, waiting for the resume to come back to the running state. Okay. In the blocked state, the thread cannot progress until something happens. For example, input output is completed or the sleep time is ended, then it will go to the runnable state. Okay. Wait, notify, all these are three methods are inherited from the class, the thread class rather. So inherited from the, just 1 minute please. Make it clear for you the screen. Okay. So these are three methods that are inherited from the object class rather than the thread class. Fine. The wait method causes a thread to wait for a notification by other threads. Notify and notify all will provide notification for those threads that are waiting, for those threads that are in waiting state. Okay. Fine. From the waiting, it will again go back to where? It will again go back to the back to the runnable state. Okay, once it is notify all is done. Okay, again from the runnable state, it will wait for the resume to go back to the running state. Okay, so that's the 5 different states of the threads. You have 5 different initial state, runnable state, running state, blocked state, and finished state. So these are 5 different states of a thread. A thread can be in any one of these states at any particular time. Fine. So there are different methods work different on different states. We have start method to move the thread from initial state to the runnable state. We have run method or resume method to move the thread from runnable to the run state. We have sleep, wait, and input output. Fine. These are move the thread from runnable to the blocked state. Now from the blocked state, when the sleep time ended or input output finished, or notify all is invoked, that will go back to the runnable state. When the thread finishes its job, then it will go to the finished state. Right? So this is the whole life cycle, or you can say the different states of a thread. Okay, the important concept at this stage is that Java program may involve, 1 minute. Fine. Okay, that's good, and it is clear to you all the thread states, right? Because you may get a question in the exam about these thread states. Basically, we used to see in the final exams previously one question from these threads about states of the threads. Right? So if it is clear to you all, that's well and good. Okay. Now, the important concept at this stage is that a Java program, yeah, this time we have THE, take home exam. We'll see inshallah what type of question it will get. This is our first time to see the take home exams, and inshallah we'll see. Hopefully you will get more easy exams, and as we all know that it is just 20%. Okay, so it'll be easy inshallah. Yeah, there is no midterm exam. You have the TMA and the take-home exam, only 2 things. Okay, the important concept at this stage is that Java program may involve a number of threads, some of which are unable and ready to execute by the processor, others are unable to proceed because they are in blocked state. On a single processor machine, only one thread can actually be running at a time, as I told in the beginning. The Java system has a component called scheduler that takes the decision about which thread to run next. The decision as when the thread execution is switched will depend on underlying operating system. Some operating systems switch when currently running thread becomes blocked, and while others allocate a block of time, like 10 milliseconds, 20 milliseconds, or in nanoseconds. Fine. Thread priorities. Of course, the thread will also have the priorities. We can also set the priority by using the method called set priority. Okay. So basically, the thread priorities is between 1 to 10. These are contained in the thread class by static constant called minimum priority, maximum priority. The minimum priority is 1. And the maximum priority is 10. So a thread inherits the priority of its creator. The main method has by default a priority of 5. That is the normal priority. The priority of thread can be changed dynamically by using this set priority method. The decision made by the scheduler to change the thread from runnable state to the running state can be quite complex, In essence, these decisions are platform dependent. It means it depends on your machine, your operating system, which means that the scheduler for different platforms have their own set of rules for selecting the threads. Platform here, it means the system in which the program is running. That's a platform. Okay. Although of interest in practice, you will find that it is not often you need to set priorities. Indeed, any program logic that relies on priorities set by the programmer will flawed, because priority ranges and implementations are platform dependent. So it is better like we leave it onto the operating system or onto the platform to have its own priority, because as we saw that the allocation of time is also depends on the platform, on the operating system, on the system. So like we leave this priorities on the but still you can set the priority by using this set priority method dynamically. Okay. So here a few questions just to brush up. Well, there are two ways to define the threads. One is by extending the thread class, the other is by implementing the runnable interface. When a thread is executing, does it continue executing until it gets the end of its code? No, it is not the case, because the threads will get time. It depends on the platform. It may get some CPU time to execute. If it does not finish in that particular time, it will be now into the runnable state again. So it will not finish at one shot. Okay. Or it may be waiting for some input output, or it may be stopped by sleep or by wait. Fine. Okay. How do you tell the system that you want to set a thread running? After creating an instance of thread, you call the start method. Right. So start method will put the thread in a runnable state which is ready to run. That you're telling the system that I want this thread to run by invoking the start method. Okay. Okay, fine. There is another two questions here. When would you typically want to define a thread by implementing runnable rather than extending? Of course, this is when we want to inherit from any other class. Like for example, in the graphical user interface programs, we need to extend from the JFrames, fine, or from the application. So in that cases where we need to extend from other classes, thread can be implemented. How do you define, create and start thread using runnable? So first we need to implement the runnable interface, override the run method. Then in the main method, create the thread object, fine, and create an instance of the class, and then create a thread object for that instance, and then call the start method. Fine. These are the steps. What is the difference between thread in the block state and one in the runnable state? Block state, it means it is waiting for something, like for example, waiting for the input output, fine. And a runnable state, it means it is ready to run. It is ready to run and waiting for the CPU to get the CPU. Fine. Once it gets the CPU, it starts its execution. Okay. Whereas block state is not ready to run, but it is waiting for something like input output or the sleep time to finish or to get notification by notify or notify all. So that's all we have from the thread class, from the thread topic. Any questions on this topic? Any questions? So of course this is our last topic. Fine. Yeah, it is most of the theory. Just to understand the thread concept, how we can create the threads in Java. Fine. That's about most things here. What are the different states of the thread? Okay. So that's about the thread topic here. We'll see, inshallah, some revision here as we have still some time. Okay, now let us take some revision here. Basically, this revision is can say from the mock exam, which previously used to get, but this time, of course, you don't have that exam. It is only the take-home exam, as we all know that. Fine, and the TMA. You know that the TMA is coming near. Okay. Please do it carefully because it takes 80 marks out of 100. So if you have a perfect TMA, you will get definitely good grade just in the TMA itself. Okay. But in all cases, you need to do submit the take-home exam, THE. Fine. Otherwise, if you are not taking the THE take-home exam, you will be marked as incomplete. That means that again you need to take the exam in the summer or in the first semester next year. If you don't submit the if you don't submit the take-home exam. Is it clear? Fine. So it is very important. It is very important that you submit the take-home exam. Excuse me. I'm sorry. Okay. When I get sneezing, I get like 4 or 5 at once, and then this is what with me sneezing is like when I get one, I get 3, 4, or 4, 5 continuously, back to back. Okay. So I was telling about the take-home exam. Take-home exam, you say it is 20%, just 20 marks it is, but you have to submit it. You have to do it and you have to submit it. There is no way that you can skip the take-home exam. If you skip the take-home exam, then you will be marked as incomplete, and you will have to take the final exam in the next semester or in the summer, in all cases. So you have to do the take-home exam. Fine, no other way. And I believe it is very simple. You have 7 days of time to submit the take-home exam. Fine. It will be good, inshallah. And do your best in the homework, because it is of 80 marks. And it is of 80 marks, and also we see that try to avoid the plagiarism. Try to avoid the plagiarism, because since it is 80 marks, there might be a tougher approach to know the plagiarism or copied contents or incomplete codes or errors in the codes. Right? So we wish everything will be simple and easy. Fine. And you have the take-home exam also, inshallah, easy and simple. Fine. Do we have the summer semester? Wallah, we don't know still, like we have the summer or not. But in any case, if it is IC, if there is a summer semester, you have it optional. You can take in summer or you can take in the first semester. So it's all depends. If you have the summer semester and you wish to take the exam in the summer semester, if you make IC, if you don't submit the take-home exam and you made it IC, then it is the case. Okay. But there is nothing to worry about the take-home exam, because it will be an easy exam, inshallah. Okay. Now here I have a file, mock exam file here. This file will just discuss some questions and its answers, how it will be, so that to get an idea about how to solve the questions in the exam. So we don't know exactly that it will be similar way in the take-home exam or it will be in a different way, because this is our first time to see the take-home exam. So we'll just try to understand what we have, and we hope our best to have simple and easy questions and fruitful questions. Okay. The first question here I'm taking from part 2. Part 1, of course, it is MCQs. So I don't think so you will get MCQ in the take-home exam, but no idea still. Part 2, we have the first question. What does the following function print when n is equal to 4? Print, or in the sense return. What does the following function? Okay. You want this to be recorded? Okay, let me just record it. M251, M257. Revision. Okay, so here's the revision file. So we have here, let's say that, sorry. Okay, fine. So we have a function, a recursive function here, as you can see. So this recursive function takes the value n as 4, and what does it will return? Fine. The base class here is when n becomes 0, it returns 1. So it goes up to n 0, and n becomes 0, it returns 1. The recursive call is n minus 1 into n. So it is 4 into 4 minus 1, that is 3. Okay. So it is 4 into 3. 4 multiplied by 4 minus 1, 3. Then 3 multiplied by 2. Then 2 multiplied by 1. And 1 multiplied by 0. So it is all multiplication, right? 4 into 3, 12. 12 into 2, 24. 24 into 1, 24. So it will return 24. Okay. Print here, it does not mean print here, it means return here. So it returns 24. So it's a recursive call. Clear? Clear, students? Okay. Fine. The next question here is, change the fun method here so that it throws an illegal argument exception with an appropriate message if n is 0. The method in the question is given like this, without this red part. So this is the method. Fine. Now we need to change this method where if n is equal to 0, it throws an illegal argument exception. So what we check is if n is equal to 0, then we call throws or they throw new illegal argument exception with a proper message. Cannot allocate the array with the value 0 or any message you can see. Fine. So if n is equal to 0, we check the condition. If n is equal to 0, throw new illegal argument exception. Illegal argument exception, that is in class from the exception, that takes in a string what you want to throw the string as a message. Okay, so this is how we can do that. Another method here, change the following method that it catches illegal argument exception, okay, thrown by the fun function, that is the above. We were calling this fun function where this fun function is here, right? This is the fun function. So when it throws this out of the method, fine, it goes to the calling method in this method. So we use a try catch here to catch that, to catch it. To catch it, it means you have to use a try catch, right? So if I take out this is the question. Fine, this is the question. So what you have to do is when you call this function may throw an exception. So we have to put this specifically this code in a try block, because this may throw a exception. Fine. So I'll put this in a try block. Now I will write a catch here for this try. Catch illegal argument exception E. And I print a message, system.out.println illegal argument. Okay. So you can see that here. So you try and a catch illegal argument exception, and inside that I print the message E. The array is not allocated, or you can say that array will not be with the size 0. Fine. Any proper message you can give. Okay. Is it clear on this question? It has two parts. It's all about the exceptions, from the exceptions. Okay. The next question here is about graphical user interface programming. Fine. Now here is given is the interface, designed interface. The question here is complete the code segment below so that it produces the layout shown in the figure. In this GUI, the context of text field labeled with number 1, number 2 will be added, subtracted, multiplied or divided based on the click on these buttons. If we click the add button, number 1 plus number 2 will be done, and the result will be displayed in the result text field. Okay. When we click on subtract, number 1 minus number 2, and the result will be in the text field result. And when we click multiply, multiplication, when we click divide, divided. Okay. Now it will give some code to you. For example, it will give this all which is in black here, label D result. So this is a label for the result. Text field TF number 1, TF number 2, TF result. So these are three text fields. Number 1, number 2, number 3. Then button BT add. So this is add button, BT subtract, this is subtract button, BT multiply button, BT divide. This is divide button. Now what you have to do is they just give you this you need to create these objects by using new. For the label, you need to call new label of result, text field, new text field, tf number 2 is equal to new text field, tf result is equal to new text field, bt add is equal to new button of add, bt subtract new button of subtract, and so on. Okay, this is to create the interface. Labels are which are just to display the text here, like you have this number 1, this is the label, number 2 is a label, result is a label, these are the labels. Okay, what is missing, you have to write that only. What is missing, you have to write that only. You don't need to write anything else apart from this. Okay, now all the interface is done, and the question here is that write the event handler for the add button using lambda expression. Now we have seen that in our previous meeting where we discussed about event programming. There are 3 methods we can do event programming. One is by using inner class, number 2 anonymous inner class or anonymous class, and number 3 lambda expression, and the most easiest one is the lambda expression. Alright, so we need to call the set on action for the button and write the lambda expression. So the question here is that to write a event handler for the add button only, not for subtract, multiply, divide, no, only for the add button. Similarly, you need to read the question and try to understand the question. What is the question here to implement? Okay. So if I go back here just to write a lambda expression for this button add, so it's a bt add upside down action E. So this is the lambda expression where it starts here. Okay, E with the arrow, open the bracket. Now what you have to do is that you need to set the result by adding text 1 and text 2, that is number 1 and number 2. So of course text to number 1 dot get text will get you the number in a text format that we need to convert or parse it to double. So I write double dot parse double of text number 1 dot get text plus double dot parse double or number 2 dot get text, fine, plus the text, the string, to convert the whole into a string, and that is put under the set text of the result. Fine, so that will put it the result here in the text field of result plus number 1 plus number 2. Fine, so this is only for the add method, or sorry, for the add event. Similarly, for the subtract event, it is instead of plus, it is minus there, and for the multiplication event, it is multiplication star there, division, a divide operator there. Fine. So this one question on event programming. Clear? Any question on this? I hope everything is clear with this event programming. Well, in the take-home exam also, you may get questions in this format or in any other format. Okay, because this is a programming course, so we are also expecting to get some programming questions. Fine. Okay. Okay. Now coming to the question number 4, this is from the collections, that is maps that we took in our last meeting, right? So the question here is, the following codes create a hash map which stores the key value pair for storing hotel name in an area code. It adds an area code, hotel name pair, display the hash map, print the collection of all hotels and get the area code for all hotels for a particular hotel. Complete the 5 missing lines as indicated in the number. So what they'll do is that they'll give the question, they'll keep this missing here, for example, which is in the red. Okay, they keep this as missing. Fine. So you have to write that. Okay. So they'll give this one. So this is a hash map called hotel map, which has an integer that is code, string, name of the hotel. The hotel constructor here, hotel catalog, hotel map is equal to new hash map of integer string. Of course, add hotel. So how do we add a pair in the map? By calling a method put, right? Put, right? So it takes argument C, that is the code, and H is the hotel name. So add CH to the hotel map. So simply hotel map dot put C comma H. That is, this is the key and this is H is the value. Right? So we use the put method. Okay. Now, what is the method to add an element in the set, like in a tree set or a hash set? In the map, it is put, right? A put method will add an element, a key pair, into the map. Similarly, there is a method to add an element in a set, like in a tree set or a hash set or a linked hash set. So do you remember what is a method? Yes, very good. It is an add method. So add method will add an element in the set. Okay, like put method in the map. Okay, now this is the method to add. The second question is iterate through the map. See, iterating through the map, of course it is given a for loop here. That means that by using a for each loop. There are two ways you can iterate through the map. One is by using the iterator interface. The other is by using the for each loop. Okay. Now you are familiar with the for loop. So we use the for each loop here also. In the question also it is given in black for here. So that means that you have to write the code which is in the for each loop. How do you get? So of course we call this hotel map.keySet to get the key, and we use that get method of key to get the value. Fine. So x will be the key and get of x will be the value. Okay. So we write integer x to hotel map.keySet, and this is given in the question. X is the key and the value is hotel map.get of x. Okay. So what you have to do is just you need to write this. That is what is there in the red. What is there in the red? Just only thing you have to write. Okay. The third question here is to print the hotels. And I print a particular hotel by using the key. So of course, we use the get method, hotel map.get of C will print you the particular hotel. Okay, hotel name, it means here. And to get all the values, to get all the hotels, hotel map.values will also get you all the hotels. Okay, simply hotel map.values will get all the hotels. Like we have the key set, we'll get all the keys. Dot values will get all the values. That is all the name of the hotels. So this one question on collections. Fine. Okay. Finally, fifth one. Sorry, we just did 4. Check the hotel map has an entry H or not. So we have a contains value of H. So to check it. Fine. So contains value, hotel map.contains value of H. We'll check whether the map has this value or not. If it has, it returns true, otherwise it will not return, it will return false. Okay, so this is one question from the collection. It can be maps or it can be sets. So is it clear? Any questions? So we say that two questions in three questions, four questions, not three, four questions in part two. That is one on recursion, one on exception handling, one on graphical user interface, and one on the collection framework. One on the collection framework. So on four different topics, four questions we saw in part two. Yeah, all was easy, and hopefully, inshallah, you will get the easy questions. Inshallah. Only thing is that you need to understand the question and fill the code. Now that's about the part two. Now let's take part three. Part three here. So part three, implement a class that will represent an AOU module in a package called AOU module. We want to be able to access AOU module from any package which can be used to collect the data about AOU module. So that means that AOU module, you need to keep it as public, right? Excuse me, just give me 2 minutes, inshallah. I will be back. I'll take some water and get back to you, okay? 2 minutes, inshallah, I'll be back, okay? Okay. Sorry that I took a break. I think you did not listen to me, or there was a bad connection. Just took a break just to have some water. Students, can you see the screen? Can you hear me clearly? Okay. Fine. Now we'll move to part 3. Part 3 has questions on writing programs. Fine. Inheritance and all. So we have this question number 1. It says implement the class that will represent an AOU module in a package called AOU module. We want to be able to access this AOU module from any package. That means that you need to make this package public, right? So add the fields for the following properties that cannot be accessed outside the class. What it means? It means that these fields to be added as private. So you cannot access outside the class. It means that the fields to be private. That is name of the module, name, number of passed student, number of failed student. 3 things. Name of course or module, number of passed student, number of failed student. Write a constructor that accepts the name of module, the number of passed student, number of failed student as an argument, and set the class properties to those. This constructor should be accessible from any package. That means constructor should be public, of course. We keep the constructor public that takes these 3 arguments. So it is a 3 argument constructor that takes the name of the module, the number of passed student, number of the failed students. Okay. Number 4, write a second constructor that takes only the name of the module as an argument. This constructor should set the name of the module to the argument and set the number of passed student and failed student to 0. The body of this constructor should be 1 line and it should call the first constructor. So you have to use this here, this of the name, 0, 0 to call the argument constructor. Fine. Now so let's see that code here for the first part, that we need to define a package AOU module and define the class called AOU module. This is the first part of the question. Number 1, what we see here, right? Then add the fields. Number 2, add the fields that cannot be accessed outside the class. So what does it mean? This means that you need to add the private fields. So we have private string name, private int number of pass, number of fail students. Okay. This is number 2. Number 3, it says what? Write a constructor that accepts the name of the module, number of passed student, number of failed student, and set the class properties to that. And it is accessible from any package. That means you need to write public constructor. So I write public AOU module, that is the name of the class, string n, the name of the module, int number of pass, number of fail, which will set to n as the name, n pass is the number of pass, and n fail is the number of fail. Okay. Now the fourth question here is, the fourth point in the question is that write a second constructor that takes only the name and set the number of pass and number of fail to 0. And it should be, the code of this constructor should be 1 line and it will call the other constructor. So it is by using this keyword. String n, just take the name, this of n0. What happens is that this will call the argument constructor which set n here and n pass, n fail to 0, as we set here 0. Is it clear to you about this constructor? Students online, is it clear to you about this constructor? No, they did not set, it just they say, what is they say in the question is this one. As we see the question here, the first constructor that says that constructor that accepts the name of the module, number of passed argument, number of fail argument, number of fail student. So 3 arguments. Fine. So it is a 3-argument constructor. And second constructor, they said write a second constructor that takes only the name, 1 argument, and set the number of pass and number of fail to 0. And the code should be only 1 line. So that is possible by this keyword in this fashion. Is it clear? Okay, fine. We look into the next part of the question, that is write a method that return the name of the module, number of pass student, number of fail student. These methods should be accessible from any package. So it is all the getter methods, right, that returns the name, number of pass, number of fail. So we write get name, get number of pass, get number of fail, right? So get pass, get fail, and get name. 3 getter methods. Okay, fine. What is the next question? Write a method that receives the user input either pass or fail and increase the number of corresponding attribute by 1. This means if the received response is pass, increase the number of pass student by 1, and if it is fail, increase the number of fail student by 1. That's it. So here you have to write a method that takes an argument that is an integer. Yeah, by setting an if condition here. Okay, so integer here, get input, the string input. If it is pass, then increment this dot number of pass plus plus, and if it is else, if it is fail, then this dot number of fail plus plus. Okay, so this is the method. 9. Number 7, write a method to this class that compares the number of pass student and the number of fail and return strings saying good results or bad results based on the comparison. If there are 15 pass students and 2 fail students, then method returns good result. It means that if the number of pass student is greater than number of fail student, it is a good result. Otherwise, it is bad result, right? So here is the method, go compare method. Fine. So if number of pass greater than number of fail, return good, else return bad results. Okay. Okay, and the last part of this question is finally add a main method here. In this main method, construct a AOU module named object M251 with 30 pass, 2 fail student. Call the method that compares the pass and the fail student in this module and print out the result. Make 10 calls using a loop to the method that increase the number of pass student by 1. So it means that get input you have to call. Okay, 10 times. By using a loop, you can call them 10 times. Okay, so we write the main method here, public static void main, create an object M251 with 30 pass and 2 fail. Okay, and we call go compare to print the result, good result or bad result. So of course 30 pass and 2 fail, it means it will print good result. And now you make 10 pass to this again. So we put a for loop 10 times and get input pass. We'll call this get input and increment the pass by 10 times. Yeah, which is this one here. Okay. So this question number 1 is all about programming, writing a class with the class attributes, the attributes of the class or the instance variables, constructors, getter, setter methods, any other methods. Fine. Finally, the main method in which you can create the objects and invoke those methods. Fine. So a simple class here. Everything is clear to you from this question number 1. Do you have any questions? Okay, that's good. We have another question here. So this is a bit more, we can say, tricky than the question number 1. That also has abstract classes and the interfaces and all. It is not just a question, one single question. Okay. So define a Java structure that can represent account, and account has a balance method which returns the balance of account as double. Now you see that structure is what? It is just a structure or a model, not the concrete class. So structure can be an interface. Okay, structure it means here an interface. So we write an interface called account that has a method balance whose return type is double. Okay, so what we write is public interface account, and we write inside the method public double balance. Of course, we don't implement this method here. We don't write any code for this method because we all know that interface does not have a method implementation. It is just a structure or a design, right? Okay. The second part here is define a saving account structure, which is an account. The structure has an attribute salary and number of months, which are set by its constructor. So now this structure saving account will have, which is again a structure. But this structure is not an interface as it has a constructor. It has a constructor. So it is an abstract class for saving account, implements the account, fine, which has salary and number of months, and has a constructor, salary, that takes the salary and number of months and set the salary, and implement the balance method that returns the balance, which is salary into number of months, fine, and toString method that display savings. Okay, so the calculation inside the balance is number of months into salary. It also overrides the toString method to return saving account. A saving account should not be able to instantiate it. So that means that it is an abstract class, and we all know that we cannot create an object of or instantiate an object of abstract class. Okay, so that's an abstract class implementation. Then define a class employee saving account, which is a saving account. So it means that class employee saving account extends saving account and implements account. Which an employee saving account object is printed, a message employee saving account which represents the object is returned. So that means that toString method. Okay. Instead of employee saving account should be able to store variable account and the saving account. So it takes those two objects. So extend saving account, implements account. This takes the salary and double month. Of course, this is from the saving account class called the super of salary and number of months, and toString employee saving account. Okay, so that's a class. So this question is on the implementation of the interfaces and the extents of the classes, that is on inheritance. So what we need to understand here is that when to write interface, when to write abstract class, and when to write a concrete class. When it said Java structure and without any constructors, without any other methods, with just a method, okay, here, so that is as an interface. We can also write it as an abstract class, but if we write interface, it is much suitable for the account. Saving account is a structure again. So this is an abstract class that has an attributes, has a constructor, balance method is implemented here, and has a toString method. fine, to display this message saving account. Then define a class employee saving account. So it is clearly given here, it is a class. Fine, it is a class, not an interface. And it's also not an abstract class because it is defining everything. So which is saving account. So extend saving account, also an account. So implements an account interface. And when the object is created, it returns the employee saving account message. So it is a two-string method. We call the instance of an employee saving. That means that instance of employee saving should invoke the account or saving account. So it means that we need to create a constructor and call the superclass constructor. So inside its constructor. So we create a constructor here for employee saving account, which takes salary and double number of months. We call super of salary. So this will call the constructor of saving account with salary and number of months. Fine. So this is how you can solve these type of questions. Is it clear to you? Is it clear to you all? Okay. Finally, we have the last question here, that is reading from the file, or that is from the file input output, and using try catch or exception handling. So the question here is, there is a question here, super, can you explain again? See, basically super is a keyword which is used to invoke the superclass constructors or superclass methods. Fine. So here the question says that the instance of employee saving account should be able to store in a variable of type account or saving account. So it means that when you create an object of saving employee saving account, this will call the superclass, that is saving account. So we call that by using the super. Super of salary and number of months will call the superclass. What is its superclass? It is saving account. So we'll call its superclass constructor by giving the salary and number of months, which will be set to the salary and number of months. Okay. Clear? Now for the getter and setter method, this is not required. Because getter and setter method, basically we put it public, and public is automatically available to its subclass. So there we don't need that. Okay. Now the last question in this mock exam is write a Java code inside a try catch block that read a file email.txt and convert and print all its characters into uppercase letters. Very simple. Import java.io because to use the files. Write a main method, put a try block, create a file object that is email.txt. The name of the file is given here. Write the scanner, put the file object inside the scanner, create a line object, string object called line, check while has next line, read the line and put the line into the to uppercase and print the line to uppercase by using the while loop. Okay, just it is reading the line and printing the line again to uppercase. And to check that we have the next line again, we have this has next method. We see that has methods of the scanner, has next int, has next double, has next line. This will return whether there is a next line to read or not. If there is a next line to read, it will say true, and you can go and read the next line. Once it finishes all the lines, this will return false. Once it is false, it will get to close the reader. And of course, for a try, you write a catch and you write the exception. File not found exception, for example, and you write the exception here. Fine. It's very simple, just to read the file contents and print it in uppercase. You may find this type of question like in reading the files and dealing with the data inside the file. And also writing to the file by using print writer. By using print writer, writing to the file. Okay. So that's all we have from this revision part of the mock exam. Any questions? You can go ahead, please. Yes, please go ahead. Yes, we have 2 links. See, you have 2 links. One link to submit the Word file, wherein which you copy all the codes and output screenshots and write the theory question, answer for the theory question. That is the Word file. So you submit that in a Word file link. The other link for the zip file, the zip file is your project file, what you do the project, right? So that project file. For example, I'll show you that here. This is my LMS here. If you are M251 or M257, yeah, you have this Word file submission. You see this link? This is to submit the Word file. This is to submit the project file, that is the zip file. Now how to get that project file is that you can go to the documents. For example, let's say that this is my project file, M251 set maps. Okay, if this is my project file, how can I get that is that you can go simply to the my documents. In this my documents, you find this NetBeans projects. Okay, you go to this NetBeans project, you find that project folder here. Zip this folder, add to the zip. Okay, so if I add to the zip here, fine. So I'll create a zip file here. I'm sorry. Let's say I'll create a RAR file here. So here, this RAR file, okay, this one, you submit that in this link. Yeah, NetBeans project IDE project link, here it is. Okay, here you have to submit this. Fine. So you check your project. What is your project? That folder will be there inside this NetBeans projects, inside the documents, NetBeans project, documents. Then you have NetBeans projects. Then you have that folder, your project folder. That project folder, you have to zip it and upload it. You can also do that also. If you can export it from the into a zip folder, you can also do that also. No problem. Okay, fine. There is a question about how many days it will take for grading the CMA. 7 days after your submission. Because we have 3 days late submission plus 4 days for grading. So almost 7 days for your submission. But keep in mind that TMA submission is very important because it is 80 marks. And take-home exam, final exam, THE, take-home exam is also important to do it. If you don't submit the take-home exam, you will be marked by default IC, incomplete. Okay, and if you mark as incomplete, you have to take the final exam next in the semester. I mean, in the next semester, you have to take the final exam. Okay. Well, it's and according to the what we see from Ministry of Education is it is not counted under the GPA, and hopefully, and this will also not be counted under the GPA. I see if it is counted in the GPA, that is well and good, because what I am guessing is most of the students will get good grades. Okay, so if they count it in the GPA, that's very good. And if they just have passed and failed without the grades not counting on the GPA, that's okay. ايوه السكرين شوتس كلها الاوتبوتس تشوف في الملف الواجب مكتوب فيها ايش يكون في السكرين شوتس. اللي تشوف الملف الواجب عندك الاوتبوتس ولا عندك الانبوتس. تمام، حتى الانبوتس والاوتبوتس الاثنين سكرين شوتس. وزيد كمان الملف اللي نعمل ريد من ملف. زيد كمان الملف اللي سجل بيانات ونعمل ريد من الملف. Yes, you have to put the text document also in the project file to test your project. All your projects will be tested, you know. Yes, the class is done. If you have any questions, you can go ahead. Otherwise, you can leave, no problem. Asad Salim, you did not put it. Is there it is in open the file to read or to write? There is no attendance, Sarah. You can leave. You are most welcome and wish you all the best for your exams. Have fun. Have fun, have fun. Exactly. Any other questions? See, if you did not include the file, it's okay. I just want that the first operation to the file is the write operation or the read operation. Write operation, then I think your code will create a file. No problem, inshallah, because it is write operation. Basically, write operation will create a file. So I think your code will create a file. عبد الرحمن نعم، هذه آخر محاضرة. الأسبوع الجاي ممكن هيكون المحاضرة، بس ما أدري، لأن الأسبوع الجاي آخر أسبوع اللي بعده ينزل التيك هوم إكزام، الفاينل إكزام. فنشوف إن شاء الله إن يجيك الإيميل أو يجيك الإيميل من BCC. نشوف هيكون محاضرة وإيش فيه يكون محاضرة، إذا في محاضرة. أوكي. الله أكبر. عفوا عبد الرحمن. تمام. أي سؤال أخرى؟ Any more questions? Okay, then thank you very much. I wish you all the best for your exams, and stay safe, stay home, stay safe. May Allah protect you all, and you do your best in your homework and exam. Thank you very much, and see you inshallah in the next semester. Thank you.